Okay, this black graph or curve is actually the graph of f of x, which is the rational function, x minus 12 over the quantity x squared minus 4x minus 32. We're asked to find the area under the curve above the x-axis between x equals 5 and x equals 6. Okay, so there's the answer right there, 0.2756, blah, blah, blah. And this red graph, dotted graph, is actually an antiderivative of this function. And there's a couple ways to write it there. And you'll notice that if I find big F, or the antiderivative of 5, I get this y value. And the antiderivative evaluated at 6 gets this y value. And the difference between these two y values is the same as the area under the curve. Okay, that's the fundamental theorem of calculus in play. But I assume that your basic question is, what's the best way to get from here to here so that we can actually find the antiderivative? So there's a couple techniques. First thing is you want to realize that this denominator can be factored, x minus 8, x plus 4. And theorems about partial fraction decomposition say as long as these are linear factors, that this can be broken apart into a over x plus 4 plus b over the quantity x minus 8. If we multiply through by the LCD, we get this equation right here. And now most textbooks will tell you to distribute the a, distribute the b, collect like terms, and then equate coefficients. But in some cases, it's a lot easier just to let x equal, for example, 8, and the a will disappear because this term becomes a 0. And negative 4 equals b times 12. So b equals negative 1/3. That goes right here. That's where this came from. And if we let a equal negative 4, the b disappears. And we can solve for a quite easily. So we get negative 16 equals a times negative 12, a equals 4/3. Okay, and so once you've rewritten the original function this way by partial fraction decomposition, the integral of this first term, of course, is 4/3 times ln of, this is supposed to be a 4, of x plus 4. Since we're going from 5 to 6, we don't really need the absolute value symbols. Minus 1/3 ln of the quantity x minus 8, or the absolute value of x minus 8, which we do need because when we put 5 or 6 in for x, we have a negative value. Can't take the log of ln of a negative number. Okay, and of course you can use properties of logarithms to rewrite this way, but f of 6 minus f of 5 gives you the same value as Desmos does when you just evaluate the definite integral from 5 to 6. There you go. And your answer is between 1. Well, no, it isn't. It's less than 1, 0.2756. So this is a very small area right here. Okay, hope that helped. If you have any questions, post a comment.